Question number 1. Let fx equals 4x upon 3x plus 1 times x plus 1 whole square. Express fx in partial fraction. So we'll have fx equals a upon 3x plus 1 plus b upon x plus 1 plus c upon x plus 1 whole square. And on the left-hand side, I should write the expression, which is 4x upon 3x plus 1 times x plus 1 whole square. Now we'll make the denominators the same as the left-hand side on the right-hand side. So a has to be multiplied with x plus 1 whole squared to get the denominator to be the same. B has to be multiplied with 3x plus 1 and x plus 1. And C has to be multiplied with x plus 1 only. Sorry, 3x plus 1. And now we have same denominator underneath each of A, B, and C. And we're going to cancel the denominators on both sides. Okay, so the denominators cancel out and we get 4x equals A times x plus 1 whole squared plus B times 3x plus 1 times x plus 1 plus C times 3x plus 1. Okay, now we need the values of A, B, and C. So what we can do is we can first make x equals, let's try to make this 0. To make this 0, we will have to write 3x plus 1 equals to 0, which means x equals minus 1 over 3. So we're going to take x equals minus 1 over 3. That will give us the value of A because B and C will get multiplied with 0 and become 0. So 4 times minus 1 over 3 equals A times minus 1 over 3 plus 1 whole squared. Okay, so minus 1 by 3 plus 1 whole squared is 4 over 9. So we get 4 over 9a here and minus 4 over 3 here. And when we cross multiply, we get a equals negative 3. Okay. Now let's find b and c. Okay, so next we can make these 0 by equating it to 0, which means x should be equals to negative 1. Okay, so we'll write 4 times negative 1 equals A will get multiplied with 0, it gets eliminated. B will get multiplied with 0, it gets eliminated. And for C, we'll get C times 0 plus 1, which gives us C equals negative 4. No, definitely I made a mistake here. X is negative 1. I accidentally took 0 here. Okay, so when x is negative 1, we get negative 3 plus 1, which is negative 2, which gives us C equals 2. Okay, now we need the value of B. To find B, what we can do is take any random value of x, try to make it as simple as possible. So I'm going to take x is equals to 0. So here we took x equals to negative 1. Okay, so let's take x equals to 0. We already have the value of A, which is negative 3. We already have value of C, which is 2. We're going to use these. So when x is 0, left-hand side becomes 0 equals negative 3 times 0 plus 1 squared, which is just 1 squared, plus B. And when x is 0, the brackets will become 1 times 1, which is just 1. So b gets multiplied by 1, plus c is 2 and 2 times 1. Okay, so we are getting 0 equals negative 3 plus b plus 2. So we're getting b equals 1. Okay. So the partial fraction becomes fx equals negative 3 over 3x plus 1 plus 1 over x plus 1 and plus 2 over x plus 1 whole squared. The first part is done. Okay. In part 2, we have to integrate these. So let's do that. Let's start the integration process. So integrate from 0 to 1. First one is negative 3 over 3x plus 1. The next one is 1 over x plus 1 and 2 over x plus 1 whole squared. Okay, so in this question, two rules of integration are being applied. One of them is that if you have an fx in the denominator and an f prime x in the numerator, then the answer of integration is going to be ln fx. Okay, but in this case, this is even more simpler because the fx, they are linear. So instead what we'll do, instead of this one, this is mostly used when fx is non-linear. So here, since fx is linear, let's even simplify things. So if fx is linear in the denominator and in the numerator you have 1, then the result of integration is ln fx over f prime x. We'll use that here for this one and for this one. And for this one, we'll use the AS rule of integration, which is if you have fx power n and fx is linear, then this gets integrated to fx n plus 1 over n plus 1 times f prime x. This is n plus 1. Okay, so let's start integrating. In fact, before we integrate, I'm going to rewrite this as 2 bracket x plus 1 whole power minus 2. Okay, now let's integrate. This will become minus 3, can be ignored, and we'll write ln 3x plus 1. And in the denominator, we'll write f prime x, which is the derivative of this, which is 3. Plus, again same rule, which will give us ln fx, which is ln x plus 1, divided by the derivative of this, which is 1. And for the other one, we're going to use the AS rule, which is 2 gets written on the side, x plus 1. Power gets added by 1, so minus 2 plus 1 is minus 1. In the denominator, we'll also get minus 1 times the derivative of this, which is already 1. And the limits are 1 to 0. So we're getting minus ln 3x plus 1 plus ln x plus 1, and then we're getting minus 2 over x plus 1 after simplifying. So when we write minus on the side, minus 2 over x plus 1, and limits are 1, 0. Okay, now we're going to substitute the limits. I think I would further like to simplify this to make the limit substitution easier. I'm going to use the log rule and write it as ln, this is optional by the way, x plus 1 over 3x plus 1, and then minus 2 over x plus 1. And now we're going to substitute 1 and 0. So when we substitute 1, we get ln, that becomes 1, and this becomes 4, and minus 2 upon 2, which is 1, first bracket, minus, when we substitute 0, we get ln 1, minus just 2, and ln1 is already 0. So we are getting ln1 by 4 can now be split into ln1 minus ln4. Then we have a minus 1, then we have a plus 2. This is also a 0. So I'm getting 1 minus ln4. Let me double check this. All right, there is a blunder right here. This, when we substitute 1 here, we get a 2 in the numerator and a 4 in the denominator, which simplifies to 1 by 2. So this was 2, this becomes 2, and this becomes 2, and this is the correct answer.